So far, we have mostly, give or take the odd snarky aside, assumed that our models and algorithms that we use in machine learning are essentially ethically neutral. I have repeatedly and quite tediously argued that the fault, dear Brutus, lies not in our models but in ourselves. But no technology exists in a vacuum, whether it is saving lives or destroying livelihoods. And given the breadth of applicability of machine learning and the depth of data and assumptions that go into those models, it behooves us to consider what the effects and consequences might be and how complicit we are with those. Let us start by considering the data, which is perhaps the less contentious element of the problem. As discussed on any number of occasions in the past, machine learning is inevitably and crucially shaped by the data that is used for training and for validation. If you train on bad data, then you can't be surprised to get bad results. And one way or another, a lot of data is bad. But how do you know? How can you really be sure of what goes into your data? We very rarely have the luxury of completely curating our data sets from the ground up. And even with such detailed individual curation, we're likely overestimating our own objectivity and encoding into the dataset our own assumptions and biases about what matters and what doesn't. These kinds of unconscious biases are almost by definition unintentional, but just because you don't notice them doesn't mean they aren't there and don't have effects. Choices made in selection and gathering of data and in modelling assumptions inevitably capture aspects of the worldview of the people making those choices. Often people will be casually blind to their prejudices and unaware of the way in which those sorts of prejudices are consistently reinforced by the monocultural aspects of their environment. As an obvious case in point, the technical education and research, and as a result of that, commercial environment was so overwhelmingly dominated by middle-class white men for so long that it could be pretty easy to mistake that for the natural order of things if one wasn't careful. For decades, the image of Playboy centerfold Lena Forsen was a de facto standard test case for the fields of image processing and computer vision research. This usage of what was essentially a soft porn image was not ill-intentioned, it was just thoughtless. But the implicit message of this image, which came across to at least some of the people, some women exposed to it, was that this scientific discipline, like all scientific disciplines, is the domain of leering straight men, while women were there to look pretty and be decorative. And what sort of humorless, man-hating termagant could possibly object to such a harmless bit of fun? This image isn't training data, it's much more visible than that. It is a flagship and iconic statement. Imagine how much more easily such unexamined biases can lurk below the surface in the invisible morass of the data. The bigger the dataset, the more its collection is likely to be out of our control. It will probably involve either automated collection in some way or collection over a very long period of time, a long history of data collection, or both of those things. Either way, there may be a whole raft of inbuilt assumptions and biases in that data collection process. We can try to intervene in this to some extent to do some curation and filtering along the way, but this becomes increasingly difficult at scale. And of course, it's just another way for us to embed our own unconscious biases. There's a good chance that we will only find out what is in the data and what it has done to our model once we've done the fitting and seen how it behaves. This is one of the reasons why testing and analysis is so important. But this requires intentionality. It requires us to actually get in there and do it. If it doesn't occur to us to look for biased or artifactual results from our model, then we're not going to find them. Of course, it's possible that someone else will, and that might be potentially embarrassing. It's obviously preferable, if we can and if we care, to try and get the problem out of the way up front by detecting it ourselves and trying to do something about it. Once again, I'd like to give a shout out here to the good people at ConceptNet Numberbatch for doing this kind of thing explicitly and making a point of it. If we're going to use the data for supervised learning, we will also require labels, and these have to come from somewhere. For small data sets, we might provide the labeling ourselves. For larger data sets, there are two other common choices. One is automation and the other is crowdsourcing or crowd working. In both cases, there will be issues of quality control. Crowdsourcing or crowd working platforms like Amazon's Mechanical Turk involve using kind of piecemeal labour, which may be exploitative. There may be exploitative labour practices inherent in that, but whether or not that's the case, it's likely that the workforce is in some way piecemeal and ad hoc. So it's difficult to tell how representative they will be of the population that we might be trying to model. And obviously they will be subject to the vagaries of the population that they have available. There are several approaches to quality control for crowdsourced labels. There will be a requirement for replication. So labels will need to be provided and validated by multiple workers, not just by individuals. But there may also be automated monitoring systems. But these give rise to unfortunate feedback loops. In particular, if labels are checked against automated classifications and unexpected outlier responses are discarded, then what's really happening there is that the system is reinforcing its own biases. In this case, the crowd workers are really being expected to rubber stamp decisions that have already been made and perhaps give them an undeserved veneer of objective legitimacy. Another issue with data collection is that of ownership and consent. Historically, researchers and companies have been extremely cavalier about data collection. Essentially, if you can acquire it from somewhere, then that'll do. Whatever you can scrape together in whatever ad hoc fashion from whatever sources across the world is fine, and let's not dig too much into the details. The explosive growth of the internet produced a free-for-all data bonanza, and every image tag on the web was fair game. Classic, standard foundational datasets like ImageNet take data from all over the internet. This was partly justified by the assumption that if you used such data to train a model, whatever remnants of the data remained in the model were so completely abstracted from their original sources as to be essentially untraceable, and so it didn't really matter where they came from. However, with the rise of very big models like GPT-3 and Big GAN, which have an enormous capacity for memorization, This is clearly no longer really the case. Data generated from these models may be novel in one sense, and yet at the same time, it is clearly a gloss on the training data that was originally used. The models learn distributions, but they do so via the medium of samples, and those samples leave traces. Does that mean that the models are plagiarizing the data? Is what they learn from the texts or images on which they're trained in some way appropriation of it? Did the original creators give their consent for this usage? Do they even know that it happens? If some future iteration of GPT can churn out on the hour, every hour, new but unmistakably stylistically similar Stephen King bestsellers, what will that do to the market value of Stephen King? If StyleGAN captures everything that it knows about some particular kind of facial feature from photographs of you, does it owe you anything for that knowledge? Is it taking anything from you? Is it like the camera stealing your soul? And once we have this data, the question remains, what is it that we are going to do with it? What problems are we going to attempt to solve? Does solving those problems make sense in general, and do the ways in which we are attempting to solve them make sense? Is our approach likely to give valid answers? And if it does, or even if it doesn't, and the answers it produces are invalid, how are they going to be used? Proverbially, if you ask a stupid question, you should expect a stupid answer. But asking stupid questions can be enormously tempting. You may not even be aware that they're stupid. People love to look for patterns and love discovering patterns, however spurious they may be. They love comforting myths and explanations as to what is going on. We like to feel like we have an edge, like we have made some discovery of a special insight, like we have been let in on a secret. Machine learning provides tools that can be useful for navigating complex data and for discovering genuine patterns, but they can also be very useful for noise mining, for imagining relationships and discovering spurious correlations, hallucinating patterns that aren't really there. This is one of the reasons why we so constantly warn against the dangers of overfitting. But the lure of such pattern discovery is very strong, and fishing expeditions are a very common way of looking for patterns in data. If you look for a lot of different possible patterns, then sooner or later you're going to find some. And it's pretty easy to cast some specious overfit as some dazzling, insightful discovery. It's very easy to overstate the significance of your discovery, especially if it happens to accord with what you wanted to show in the first place. This is one of the reasons why you should never trust a p-value. Significance tests are the last refuge of the scoundrel. It's all too common to bandy around irrelevant metrics for marketing purposes, to make vapid claims about your percentage accuracy on ImageNet when you're not even doing image classification. In a commercial environment, it's commonplace to have these kinds of pointless bits of box ticking in the marketing materials. But this kind of misrepresentation and what's known as p-hacking is also all too common in scientific research. People do it because it has value. It is persuasive. It helps to sell your research and your results. But these kind of invalid metrics are not helpful, and they may be positively dangerous. Whether or not the patterns that you detect or claim to detect are real, you then have to face the question of what it is that will be done with them. What is your model even for, and what effects will it have? If you are discovering patterns in economic data, patterns of changes in financial value, and you exploit those, will those exploitations lead to instability, or will they lead to increasing wealth inequality? If you are producing information that helps with medical diagnostics, is that going to improve treatments and make things better, or is it going to lead to particular classes of patients being marginalized and excluded? What does it mean to identify or claim to identify traits that may be seen as socially undesirable? Traits such as criminality or minority sexualities. What exactly do these sorts of labels actually mean? Are they perhaps just proxies for existing structures of inequality and patterns of disenfranchisement? How much do they just codify prejudices and furnish them with a veneer of objectivity that they totally don't deserve? What kind of safeguards are there for the deployment of your model? What exists to protect people from any harmful consequences of its use? In a few contexts, notably medicine, there exist significant regulatory structures and rigorous testing is required. But even in those contexts, errors can sometimes creep in, and sometimes with devastating effects. In most other contexts, however, it's the Wild West. There are very few regulatory structures. Most machine learning is deployed pretty much willy-nilly in at best a self-policed fashion, and to the extent that there are regulatory bodies, they are hopelessly under-resourced and pretty much toothless. Commercially and in a scientific context, there are always incentives for cutting corners, for overselling capabilities and understating problems. Of course, in lots of contexts, that doesn't matter. Lots of applications are frivolous and trivial, and it's hard to see how they could ever impact anyone harmfully in any way. But it's very difficult to be sure. How can you know that your little Mickey Mouse model is not in some way paving the way for some terrible future dystopian use case? Businesses deploy machine learning for insight and for automation to improve efficiency and cut costs. They want to improve their processes. They want to increase their profits. They want to undermine their competitors. Governments do all of these things as well. In many real senses, nations are corporate bodies. Governments also deploy machine learning for intelligence gathering and security and social control. All of these applications can involve ethical conundrums. What kind of social norms is it reasonable to enforce? Where does that start to impinge on individual liberties? At what point does a commercial drive to increase viewer engagement give way to the need to avoid radicalizing large tranches of your audience? Does the notion of corporate responsibility even mean anything? These things are not in our control and maybe not in anyone's by now. Companies like YouTube and Facebook are large enough and entrenched enough to be essentially laws unto themselves. And perhaps it doesn't matter in the end. Perhaps we will all be more than happy to sleepwalk into a deep learning driven utopia when the tech bros take on climate change and win. Or perhaps there'll be a tectonic shift in public perceptions. Perhaps there will be a neo-Luddite revolution and armies of villagers wielding pitchforks and flaming torches will mass in Silicon Valley and swarm all over Gower Street. Perhaps it's too late to do anything about that. All that is up to us is how we use the machine learning technologies that we have at our fingertips, how we make use of the knowledge that we have, and what kind of problems we attempt to solve. And we can try to do it thoughtfully and deliberately and ethically in our own little ways. We can do as best we can not to make things worse.